Alright, good everyone. This is Ajaks tutorials. Once again, welcome to my YouTube channel. Alright, so yes, we're just testing the video, okay, to see how good the video is. Alright, so yes, we're going to be treating chemistry today, and we're going to be treating some series of jam pass questions. Okay, alright, so I'm going to be giving out some questions, and I want you to pause the video, read the question by yourself, then try to attempt it before you look at what my solution. Okay, so you're going to see the question on your screen now. Let's start with question 1. 56 centimeter cube of a gas at STP weighs 0.11 gram. What is the vapor density of the gas? What's the vapor density of the what? Of the gas? If A 11 points, so my option A is 11.00, option B 22.00, option C 33.00, and option D 44.00. It now said something else. It said the molar volume of the gas at STP is what? 22.4 dm3. So yes, the molar volume is what? 22.4 dm3. Alright, the molar what? Volume of the gas. Okay, now this is very, very simple. Alright, so this is basically what mole concept. So I go again. 56 centimeter cube of a gas is weighed at 0.11. So the volume of the gas is what? 56 centimeter cube. Do we understand? That's the volume of the what? Of the gas, 56 centimeter what cube. They now said something else. They said it is weighed at 0.11 gram. So this means the mass is what? 0.11 gram. Do you understand? What are they asking you to find? They said, what's the vapor density? You have to note that vapor density is equal to what? The molar mass over 2 is half of the what? The molar mass. Are we getting it? Now, it's simple. We are going to apply what? The mole concept. So I'm going to be giving you some formulas for mole, so just take note. First, mole is equal to what? The mass over what? The molar mass, capital MM. Alright? This is the first formula. Another formula is what? Mole equal to what? Volume of a substance over volume at STP. That's what? The molar volume, 22.4. Now, since we know this, there are actually more formulas for mole. Right? Since we are based at this question, let me know what digress. Okay? So, since we know these formulas for mole, we can now simply say, okay, mass over molar mass, are you getting it? Equal to what? Volume over 22.4 dm3. Now, you have to be very, very careful. The question was in centimeter cube. These are the tricks for jam. Alright, so let me get my next marker. So this is in what? Centimeter cube. You have to be what? Very, very careful. Now note this conversion. As a student, you should know this conversion. When you want to convert 1 dm cube, alright, to cm cube, you multiply by what? 1000. You what? Multiply by what? 1000. Do you get? So from dm cube to cm cube, you multiply by what? 1000. Now what we're simply going to do is what? The mass they gave us as 0.11. Alright, so okay, let me just write it. 0.11. Are you understanding? Over now the molar mass. They give us molar mass. That's what we're looking for. Yes. So molar mass equal to the volume. I say you should multiply. Okay, now this is in cm cube. Do you understand? So let me just change it to cm cube. It's the same thing. Alright, so what's my volume? My volume is what? 56 over, now let me change this guy to cm cube. If you decide to change one to dm cube, you see the same thing. Divide by what? 1000. Do you understand? Now this is what? 22.4 times 1000. Do you understand? Now what are we going to simply do? Cross multiply. Okay, now I want to teach you, because this is a jam question, so I want to teach you in a method that you don't really need to use calculator. Okay, but just watch me. 0.11, all right, times 22.4 times 1000 divided by what? 56. This is giving me my what? My molar mass. Do you get it? It's giving me my what? My molar mass. Now watch. 0.11 means 11 over 100. Hope you know that. Times 22.4 means 224 over 10. I believe you get it. times 1000 divided by what? 56 equal to the molar mass. Are you grabbing? Now, watch this. 1, 2, 3. 1, 2, 3. Are you getting what I'm doing now? So, this is cancelling out. This is cancelling out. This is cancelling out. What am I going to be left with? I'm going to be left with what? 11 times 224 over 56 equal to molar mass. Now, with this, you can now simply what? Punch on your calculator, because it's easier to calculate this than to calculate this whole thing. Alright, so I'm with my calculator here. So let's do it together. 11 times 224 divided by 56, 44. Very good. So my molar mass is what? 44 gram per mole. Now you have to be very, very careful. Be very, very what? Careful, because this is a JAMB question. Alright, you have to be very careful. JAMB, they have their method of what? Trashing students. Now watch this. This is 44 gram per mole. This is correct. But you are asked to find vapor density, not molar mass. And you can see 44 now. A student that is not really calm can just quickly go for option D, which is wrong. Alright? So be very, very what? Careful. So my vapor density is equal to what? 44 over what? 2. Vapor density is finally what? 22.0 gram per mole. Option what? B. Do we understand? Let's move to the next question. Alright, I'm going to sit in your screen now. Let's go. Which of the following equilibria is more like a polar form of what? Equilibrium. Which of the following equilibria is shifted to the right, okay, as a result of an increase in pressure? So which of them will be shifted to the right as a result of what? An increase in pressure. Alright, now this is very, very simple, okay? So this is basically chemical what? Equilibrium. So before then, I want to just quickly brief you guys on chemical equilibrium. Alright, I'll be very, very fast, okay? Now, when you're talking about chemical equilibrium, we have three main conditions, alright, to take note of. Okay, we have three main conditions to take note of, because Lussac actually gave us a principle, alright, which says that what? When there is a shift in the system, alright, there's going to be a change to annul or neutralize the effect of that shift. Do we understand? That's what Lussac's principle. So Lussac talk about temperature, talk about what? Pressure, and he talked about what? Concentration. Do we understand? So let's quickly go to this pressure guy. Now, for pressure, if pressure is increased, in a system, it will favor the side with the least number of mole. I go again. If pressure is increased, it will favor the side with the least number of mole. I will explain. Now, if pressure is decreased, it will favor the side with the what? The more number of what? Of mole. Now, what do I mean? Now, when you're talking about number of mole in this case, actually this is meant to be pressure. If pressure increases, volume decreases. Yeah, because of Boyle's law, alright? They are inverse proportional. But now, let's go. Pressure and least number of mole. Pressure decreasing and more number of mole. Now, we are going to look at this whole system and see which of them will shift to the right, which of them will favor the right if pressure is increased. Do you get it? Now, let's go. Let me start with option A. I'll do all of them one by one so you can understand the meaning of least number of mole. Let's start with option A. We have H2 and I2 to give 2HI. Alright? Now, if I increase pressure in this system, what is going to happen? That's basically what they are trying to tell us to do. Alright? Now, let's calculate the number of mole in this place. This is 1 mole, 1 mole. So from the left, how many moles? Let me use my red marker. So from the left, 1 mole, 1 mole. Alright? 1 mole and 1 mole. From the left, how many moles? 2 moles. 2 what? Moles. From the right, 2 moles. Now, in this case, pressure will not have any effect. Yes, because they have the same equal number of what? Moles in both sides of the what? Equation. Alright? Now let's check this guy. This place is what? 2 moles. And this place is what? 1 mole. Alright. Now, I said if pressure is increased, it favors the side with the what? The least number of moles. So if I increase pressure in this place, where is the least number of moles? So it's going to favor the what? The right. We have seen the answer actually. This is the answer. Alright, but let's go through everything. Now, this guy, how many mole? 1 mole. How many mole here? 1 plus 1, 2 moles. How many moles? 2, 3. 2 moles, 3 moles. Do you get? Now, if I increase pressure, if favor the side with the least number of moles, for this guy, if favor what? Left. Because here is the least. For this guy, if favor what? Left. Because 1 is the least. For this one, if favor what? It will not favor anyone because pressure, the number of moles is the same. Now, please take note of this thing. It's outside this question actually, but it's something to take note of. If there's a condition or there are conditions that pressure will have no effect on the equilibrium position. The first condition is if it's not a gaseous system, yes, pressure will have effect on only gaseous system. Alright. The second one, pressure will not have effect if they have equal number of moles of volume. Yes. Alright, so I believe we are clear. So the option is what? Option B. So option B is legit, yes. If I increase the pressure, it favors the forward what? Reaction. That's towards the what? The right. I believe we are clear. Alright, so let's move to the next question. To the next question. Alright, so it's going to appear on your screen now. It said CH3 C3H8 plus 5O2 to give 4H2O and what? 3CO2. Yes, they say from the equation above, alright, the volume of oxygen at STP required to burn 50 centimeter cube of propane is, so it's very, very simple actually. Yes. What are they asking you to do? They actually find the volume of this guy. Alright, that's oxygen. That will be required to burn 50 centimeter cube of what? This guy. So please, you have to take note. Our case study about oxygen and propane. And this propane, they said is what? 50 centimeter cube. Do you get what I'm saying now? Alright, let's go. Now, most times your question won't give you this equation. Yes. So it's very, very important for you to know how to write the equation of every hydrocarbon combustion. Alright, so I'm going to write it now. So please commit it to memory. The combustion for every hydrocarbon is given by what? CX HY. Are you getting it? CX HY plus bracket X plus Y over 4 O2. Do you understand what I'm doing? To give XCO2 plus what? Y over 2H2O. Yes, this is the equation for the combustion of every hydrocarbon. But before we start this question, let me show you that it's actually very, very correct. Alright, let's go. In this case, what is my X? What is my Y? Now, CXHY. So X is 3 and Y is what? 8. X is 3 and Y is what? 8. Very, very what? Simple. Now let's substitute. C3H8 plus, what's my X? 3 plus what? What is my Y? 8 over 4 O2 to give what? What's my X? 3 CO2 plus, what is my Y? 8 H2O. Y over what? 2. Do you get? Now let's complete it. C3H8 plus 3, 8 over 4 is 2. 2 plus 3 is what? 5. O2. To give what? 3 CO2 plus 4 H2O. Param. We have gotten the what? Equation. Although CO2, H2O, anyhow you want to put it, it's the same thing. Alright? Now let's move to our question proper. So they said, what is the volume of O2 that will be needed to what? That will be produced from the combustion of what? 50 centimeter cube of what? Propane. Alright? Yes. Now it's very, very simple. So we're going to be applying what we call Lussac theorem. Alright? Yes. Lussac theorem. So Lussac theorem tells us that we can actually relate number of moles and volume. Yes. We can relate number of what? Moles and volume. Now I'm going to be doing it and it is very, very easy. The first step when you see a question like this that includes combustion, right? Most this is the kind of question I'm going to see in your jam actually, because this is jam pass question. Alright, now the two guys are propane and O2. Okay, now what is the mole of, what's the stoichiometric mole of propane? 1 mole of propane to give what? 5 moles of what? O2. That's the first step. Do we understand? Now the next step is what? They said how many oxygen will be produced from 50 of propane? Simple. 50 centimeter cube of propane. X cube of what? Oxygen. Ajaks. Why are we relating mole and volume? Yes, Lussac showed us we can do that. Alright, now basically we simply do what? 1 equal to 5, 50 equal to what? X. What might X be? 50 times 5, which is what? 250 centimeter cube. Option A. You can see jam question is not actually very hard. Yes, you just need to know some steps. Alright, so let's move on. He said, you're going to see it on your screen now. Yes, good. So which of the following solution we have a pH less than 7? Which of the following solution we have a pH less than 7? Is Ajaks, are we going to know pH less than 7? No, don't worry. Alright, so let's look at what we call the pH scale. The pH, let me write it how my senior scientist said we should be writing it. So pH scale. Yes. Now, let's go to a pH scale. So let me draw a scale. Right? I'm not an artist, so my handwriting is not really straight. Alright? Now, we have 7. Let's start from 0 and let's end at 14. The pH was scale. Good. Now, you have to understand something very important. Acidity increases. This I want to explain now. If you can pay attention, you are going to understand this properly. Alkalinity decreases. Are we getting it? Now, what do I mean? From 0 to 7 is acid. Not acid actually, it's acidic. Now, from 7 to 14 is what? Alkaline. That means if you are hearing a pH of, let's say 20, not 20, kilo day. Let's say pH of 6. This is what? Acidic. But now, is this a weak acid or a strong acid? That's what we are going to be knowing now. Alright? So let me use this other marker so you're going to see it properly. Now, from 0 to 7, acidic. From 7 to 14, basic. Now, this means acidity increases and this means alkalinity decreases. Now, if you are coming from 7 to 0, your acidity is increasing. This simply means that a pH value of 2 is more acidic than a pH value of 5 because it's what's increasing. It also means that a pH value of 8 is 8 to be somewhere here, Abby, is less basic or less alkaline than a pH value of 13. It means that 13 is more alkaline than what? 8, but 2 is more acidic than 5. Do we understand? Yes. Do we understand? Alright, so now let's move to the question proper. So they said which of the following will give a pH less than 7. So if it's less than 7, it is what? Acidic. So they are trying to tell us which of them are what? Which of them is acidic. It's very, very simple actually. Very, very what? Simple. Now, let me explain. There's something we call weak and strong acid. Alright? Weak and strong acid. So I want to explain and give you something very important. So please make sure you're following me. Make sure you're following me. Yes, make sure you're following me. Alright. Now, Na2SO4 is a salt from the neutralization of sodium hydroxide and H2SO4. Now, sodium hydroxide is a very, very strong alkali. Now, start writing. Alkali. Very, very strong alkali. H2SO4 is a very strong acid. Now, NaCl is what? A salt as a result of the neutralization reaction between NaOH and HCl. Now take note, HCl is also a strong acid. Now, if strong and strong meet, what will happen? Neutral. If strong and strong meet, what will happen? Neutral. Good. So this is a neutral salt. This is a neutral salt. We are looking for a salt that has a pH less than 7. In other words, we are looking for a salt that is what? Acidic. Now, let me quickly give you a table. So before I read the answer, you can already tell your answer. Let me give you a table. Now, to test if it's acid or not, when you have strong and strong, it gives neutral. When you have strong, let's say this is acid and this is base and this is salt. You get? Now when you have strong and strong, it gives neutral. When you have strong and weak, it gives what? Acidic. When you have weak and strong, it gives what? Basic or alkaline, anyone you want to say. Now when you have weak and weak, it gives what? Neutral. Good. So strong and strong gives neutral. Now let's go. This one. Let me use this one. NH4. Are you getting it? Is what? NH4Cl is a salt produced by dissociation of what? NH4OH, ammonium hydroxide, and HCl. Now take note. This is a what? A weak base or weak alkaline. The what? Weak base or weak alkaline. Now HCl is what? A strong what? Acid. So what are we having in this table now? Weak and strong, acidic. So our answer is what? Option D. But let's try option C. Yes, let's try. There's no harm in trying. I'll be ahead. So let's try option C. Now, Na2CO3 is a salt from what? Sodium hydroxide and what? H2CO3. This is called trioxocarbonate 4 acid. Now, why is it 4? Let me quickly do oxidation number. So 2 plus C minus, oxygen is minus 2. Alright? Minus 2 bracket 3. So 2 plus C minus 6 equal to 0. Everything is equal to 0. You get ahead. So we now basically say what? C is 2 minus 4 minus 4. Bring it here. 4. So this is what? Trioxocarbonate 4 acid. Alright, very good. Now, this is a weak acid. Take note. H2CO3 is a what? A weak acid. Alright, now, since we know that, I believe we can actually complete the whole answer. Weak acid and strong base. I mean, weak and weak, neutral. Weak and weak, neutral. You get? Weak and weak, neutral. What else? Weak and strong, basic. Strong and weak, acid. So we're looking for strong acid and weak base. And what's my strong acid here? My strong acid is, all of them are actually strong acid except this guy. But what's my weak base? My weak base in this question is D. Do you get this now? So option D is correct. I believe we are clear. It has a pH of, sorry, wait, weak acid. I said weak acid. Yes, weak base, that's correct. So yeah, we are done with the video. So do well to subscribe if you are watching this. If you have not subscribed, just click the subscribe button. Yes, our YouTube channel will be launching very soon. I don't want to dish out the date. And space flyer. Thank you very much.